Okay, so the C grade questions. First one. Shapes that you need to know. Cuboid. Well, we talked about a cuboid earlier. Cuboid is basically a rectangular shaped box. Okay, rectangular or with a square face like a Jaffa cake. So that's your cuboid. A tetrahedron is like a pyramid, except rather than the square base, it's got a triangular base. So basically, all its faces are triangles. So you'd have a triangle, you'd have a triangle, and then underneath there would be a triangle as well. So that would be a tetrahedron. Triangular prism we spoke about earlier when we were looking at nets. That's your Toblerone box. So that's your triangular based prism. And an octagon is an 8-sided shape. I can't remember to draw an octagon. Anyway, it's got 8 sides. So look, 2, 4. No, so that would be a hexagon. 2, 4, 6 would be a hexagon. So I need another 8. 1, 2, 3, 4, 5, 6, 7. That's a 7-sided shape. So if we had that, that would be an 8-sided shape. That's a bad drawing, but basically what we want is 8 sides. Okay, so that should be an 8-sided shape. Right. So it's got 5 faces, 3 of which are rectangular. So a face is one of the sides of the shape. And a box has got more than that, and only 3 of which are rectangular. Now if you think of your Toblerone box, each of the long faces is rectangular, and there are 3 of those, and then you have the 2 triangular ends. So that is triangular prism, which is R. 12 edges, each one of these bits are the edges. And the one that's going to have 12 edges is 1, 2, 3, 4, 5, 6, 7. It's the cuboid. So the cuboid has got 12 edges. All its faces are triangular. That one, which is the triangular prism. The tetrahedron. And the one that's not the 3-dimensional shape is the octagon, because that's just flat. So that's S. So there's only 3 marks for that, even though you have got 4 answers to give. So you get 3 marks for getting them all right, 2 marks for getting 1 wrong, 1 mark for getting 1 right. Question 15 is a bearings question. Now, a bit of learning here. You need to know that bearings are always measured from north, which is 0 degrees, as an angle turn in that. So north, 0 degrees is always north, and then you're measuring in an angle turn in that direction, which is clockwise from north. And you go around and you would write, they know 3 figure bearings, so if it's less than 100 degrees, you would put a 0 in front of it. Find and write down the bearing of Blackpool from Hollywood. So from Hollywood means Holyhead, not Hollywood. You are standing at Holyhead with your compass. You're starting at north and you're turning around until you're pointing directly at Blackpool. So the line of sight that you're measuring is that one, and the angle that you need is that one, clockwise from north. Now again, this is not that easy on a reduced paper to use your protractor, but this would be easier on the full paper. So this time, the centre of the protractor needs to be on Holyhead, and 0 needs to line up with north. So there you go, so there's my 0, and now I've got to measure around as far as Blackpool. My line doesn't cut my protractor because it's been reduced, so I'll drag that further along. So 0, 10, 20, 30, 40, 50, 60. What have we got there? 60, 64 degrees. That's about 64 degrees. So as a three-figure bearing, you would write it as 064 degrees. So there'd be 1 mark for that. A fishing boat F is anchored in the bay. The bearing of F from Llandudno is 345 degrees, and from Blackpool it's 280 degrees. By drawing suitable lines, mark the position of F on the above diagram. Okay, so I'll do this in a different colour so we can separate the two out. So of F from Llandudno, so I'm going to put my centre in Llandudno and line 0 up with north, and it's 345 degrees, so that's a long way around. Okay, we're going, it's always measured clockwise from north. So it's always going to go 10, 20, 30, blah 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 blah. 340 is there, 350 is there, 345, unfortunately I've scribbled over where I put that north, so that was daft of me, but too late, is somewhere on that blue line. This angle all the way around there is 345. Let me just check that. I haven't done 355. Nope, that's fine. So the ship is on there somewhere. Now, in order to work out where on that line it is, I need to fix its bearing from Blackpool. So from Blackpool, it's 280 degrees. Move the centre of my protractor to Blackpool. 0 at north. And then now I'm travelling around again, but to 280, which is there. Put a dot from Blackpool through the dot, and where those two blue lines cross is where the fishing boat is. Okay, so marks for that, 3 marks. 1 mark for the correct line from Blackpool, 1 mark for the correct line from Llandudno, and 1 mark for showing me where those two cross is where the fishing boat is. Total for the page 7. Okay, exchange rates. While on holiday in America, Catherine bought a camera for $470. Colin, while on holiday in Spain, bought the same camera for €324. The rates of exchange at the times the cameras were purchased was £1 is $1.88 and £1 is €1.44. Showing all your working, find out who purchased the camera for the low price and write down the difference in the prices. Okay. So if we were changing pounds into dollars, for every pound we spent, we would get $1.88. So if we had £10, we would get 10 times that. So changing pounds into dollars, we'd multiply by that. If we want to go backwards, if we want to change dollars into pounds, we need to do the opposite of multiplying by that, which is dividing. So Catherine's camera in pounds so we would do $470, that dollar symbol, divided by 188, we'll turn it into quid. 470 divided by 188, £250. So that's how much in our money the camera cost Kath. Then we would do the same thing for Colin, but he used euros. 324. and the exchange rate for euros is 144. So we do 324 divided by 144. 225. So Colin paid the lower price. So find out who purchased the camera for the lower price. Colin. The difference in the price was £25. So 1 mark for the method of working out caths, 1 mark for the method, and 1 mark for getting it right. 1 mark for the method of working out Collins, and then 1 mark for getting it right, and then 1 mark for making the right decision at the end. Oh, excuse me. Okay, question 17, graphs. Using the graph paper on the following page, draw the graph of the straight line y equals 2x minus 3, values of x from minus 2 to plus 3. Okay, so let's see if I can fit this on the screen at the same time. Right. So, y equals 2x minus 3 is a rule that links the x coordinates and the y coordinates. And we want values of x from minus 2 to plus 3. So first of all, I've got to decide on my scale here. So I'm going to go 1, 2, 3, 4, minus 1, minus 2, minus 3. We don't need to go that far, but that fits the page. Don't know what my y's are going to be yet. Now, if I put x as 0 into that, because that's an easy one to work out, because 2 times 0 is 0, y is negative 3. So x equals 0. If x is 0, y will be 2 lots of 0 take away 3, which is minus 3. So that coordinate is minus 3. In order to draw a straight line, you only need 2 points, but it's usually worth having more than 2 points, because then if you made a mistake, they won't lie in a straight line. So 0 minus 3 is 1. Then I'm going to put x as 1 in. So y equals, now, so instead of 2 times 0, it's going to be 2 times 1 take away 3. 2 times 1 is 2, take away 3 is negative 1. So x is 1, y is negative 1. So I want one more, so let's go for x is 2. Y equals 2 times, instead of x, 2, take away 3. 2 2s are 4, take away 3, 1. X is 2, y is 1. So I'm going to plot those points. So I've got to make sure that those y coordinates fit on my scale. So I'm going to go 1, 2, negative 1, negative 2, negative 3. Let's plot the points. 0, negative 3. 1, negative 1. 2, 1. Now, if those lie in a straight line, I'm really confident that I've done that correctly. If one of those knocks out the straight line, I've made a mistake, I need to go back to my maths. Looking at that by eye, I'm feeling pretty good that that's going to lie in a straight line. Yes, it does. And you draw the line beyond the points that you've plotted, because that line just goes on and on and on. It's just I've chosen those values. So that's the graph of the straight line y equals 2x minus 3. So you're going to get marks for plotting 2 points and a mark for drawing the line. 3 marks for that. On the same graph paper, draw the line y equals negative 2. write down the coordinates of the point at which the straight line y equals 2x minus 3, which we've drawn, cuts the line y equals negative 2. Okay, so y equals negative 2 is basically saying the y coordinate is always negative 2. So here's the y coordinate. So anywhere along this line here, doesn't matter what the x coordinate is, the y coordinate will always be negative 2. So this is the line y equals negative 2. So where the 2 cross is there, which is going to be 0.5, half negative 2. So you get 1 mark for each of those coordinates. Okay, so depending where you've done your workings, you've got 5 marks there, and you've got 2 marks there, which are 7. And then on this page, you've already got the 3 marks for the work on the graph. Question 18. Anne decides to buy a new turbo washing machine. She notes the prices shown above at Sam's electrical shop and at Discount Electrics, and buys the machine in the shop offering the lowest price. In which shop does Anne buy the washing machine, and how much cheaper is it in this shop than in the other? Okay, so we've got to work out, we've already worked out that one, that's how much it's going to cost her, £408. In this shop, she has to pay the value added tax on top of the £330. Now, in 2008, value added tax was 17.5%. It's currently 20%, but we'll work with that. So first thing we have to do is to work out what 17.5% of £330 is. Now, as I've said to you, work out percentages by turning them into decimals as you write them down. 17.5% would be 17.5 pence written in pounds. So if you're writing 17 pence in pounds, it would be £0, decimal point 17. So the extra half would be added on like that, and you would times that by 330. So let's do the maths. 0.175 times 330, so £57.75 is how much VAT it will cost. So the cost at Sam's shop will be 330 plus 57.75, £387.75. So in Sam's shop, Anne would be paying that much. In Discount Electrics, she'd be paying that much. So it's cheaper in Sam's shop where the machine is 408 take away 387.75 £20.25 cheaper. Okay, and that's the question where you'd be marked on your quality of written communications. There'd be a mark for how you explain that. Okay, so full marks. There's 1 mark for working out the VAT. There's 1 mark for the method and 1 mark for getting the total cost in Sam's shop, and then there's a mark for making your decision and explaining what the difference in cost is. So for that page you've got 4 and probably 3 carried over from the previous page, so 7 for that page. Okay, so we're up now to the questions that are common to both the higher and the foundation tier. So it looks like it's another bearings question, but in fact it's a triangles question disguised. Now, this isn't an angle properties question, this is a Pythag question. And as soon as you see a right angled triangle with 2 sides given on a foundation tier paper, you don't have to worry about trig. There is no trig, but there is Pythag. So the first thing to do is to square everything that you see. So we do 95 squared, 9025, and 55 squared, which is 3025. Okay, and you're already on your way to marks with this question. Right, so we've done that. That's the automatic trigger to your brain to do that straight away. Let's have a look at the context. The diagram shows 3 points, A, B and C, which are on level ground. Point B is 55 meters due east of A. So there's A, north, east, 55 meters. The point C is due north and A is 95 meters from B. Calculate the distance of AC, giving your answer to an appropriate degree of accuracy. Right, so it's a right angle triangle. Pythagoras rule finds a relationship between the 3 sides in a right angled triangle. And you can use that to work out a missing side. If the side that you're trying to find is the longest one, then you add the 2 squares that you've got. If the side you're trying to find is one of the shorter sides, you take them away. So with this one, the longest side is always opposite the right angle. It's called the hypotenuse, but you don't need to worry about that. So that's my longest side, I know it. So I'm not going to be adding these. So I'm going to take them away. $6,000. So what we've done is we've taken the original sides and squared them. Taken those away, and that tells me what the square on that side is going to be. It's going to be 6,000. But I don't want the square, I want the side. So I'm then going to do the opposite of squaring, which is square rooting. So it's square root of 6,000. So on your calculator, it's the square root button. Gives you it like that. We need to turn it into a decimal. So it's 77 point blah 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 blah. But we want to give it to an appropriate degree of accuracy. Now, because we're working with big numbers, 77 is an appropriate degree of accuracy. 77 and 1 decimal place would be appropriate, but anything else wouldn't be appropriate. So if we're going to give that to 1 decimal place, we look at the next one along, it's 5 or bigger, so that means that we round that up to 77.5 meters and then put 1 dp after it to show that that's what we've rounded it to. Or we could have written it as 77 and put 0 dp. Pythag is an easy thing to learn. If you haven't done it, go onto the Jones and Sums site in the foundation tier, look for Pythagoras, print them off and have a go, watch the video, but it's the same steps every time. You square the 2 sides you're given, then you make the decision, am I adding or subtracting, and then you square root the answer from there, and that's it. 4 easy marks. So the 4 marks there, you're going to get a method mark for correctly squaring, an answer for doing the subtraction, and then an answer for doing the square rooting and the appropriate degree of accuracy. Okay, another higher tier crossover question, mean of grouped data. The heights of 107 Christmas trees were measured to the nearest centimetre. The table below shows a grouped frequency distribution of the heights. So the way that this works is that I know there are 24 Christmas trees that are between 191 and 197 centimetres tall. But I don't know exactly what they are. They could all be 191. They could all be 197. You don't know. So we have to estimate by saying that we think the 24 Christmas trees are all the halfway point. So we need a midpoint. And the midpoint is halfway between 191 and 197. So halfway, the easiest way to do that, if you can't logically work it out in your head, is add the two numbers together and divide by 2. So 194 is for the first one. Then 198, add 204, divide by 2, 201. 205 plus 211, divide by 2, 208. 212 plus 218, divide by 2, 215. So what I'm saying is that I've got 24 trees that are 194 centimetres high. 35 trees, 201, 28, 208, and 20, 215. Now I need the mean height. So I need to know what the total height of all those trees are. So the 24 trees that are each 194 will have a total height of 4656. The 35 trees that are 201 high will be 7035. 208 times 28, 5824. 215 times 20, 4300. So I'm looking for the total height of all the trees. I know those 24 have got that total height, those 35 have got that total. So of all the trees, I'm now going to add those together. So from the top, 4656 plus 7035 plus 5824 plus 4300. So the total height of all the trees is 21,815 centimetres. And I want the mean height of one tree, so I've now got to divide that by the 107 trees that we've got. So divide by 107 equals 203.9. Yeah, to one decimal place. 8, the next one is 5 or more, so that rounds up to 203.9 centimetres. And that seems like a sensible answer, because 203 is going to be in that one, which is where most of the trees are. So I'm fairly confident that that's the right answer. Now that might seem like a complicated thing to do, but if you practice it, if a mean of group data comes up, it's the same method every time. So if you practice it, it's easy marks. Again, join the Sum website, foundation tier, take a look in the topics for mean of group data, and it's easy marks if you're prepared to put the time into the practice. So there's going to be 1 mark for the midpoints. There's going to be 1 mark for the method of multiplying and adding, and 1 mark for getting it right, and then 1 mark for your overall final answer for dividing by 107. 8 marks of the page. And then we're on to the last question, which is trial and improvement. And again, just like Pythagoras and mean of group data, it's quite a long process, but if you're prepared to practice it, it is quite a straightforward thing to do. Let's just zoom in a bit. So a solution of that equation lies between x equals 1 and x equals 2. Find the solution, giving your answer to correct to 1 decimal place. Now, using your calculators, this is pretty easy because you can just type it in as you see it. Where you have an x, if you think that an x, if you explode it outwards, becomes a bracket. Okay, now we've got these brackets here. Okay, so take where you see an x, we're going to put a bracket. Now we know that the answer to that equation is somewhere between 1 and 2. So the best place to start would be halfway. So we're going to try x equals 1.5. So in our equation, where there's an x, we explode it and put 1.5. 2x explode 1.5, take 5. And then we can type that onto our calculator exactly as we see it. So bracket 1.5, cube. Some calculators have got, oh there we are, we've got one there as well. We've got the x cube button there, so we can press that and it's straight there. Looks exactly as it does there. Plus 2 bracket 1.5 take 5 equals. So that's an answer of 1.375. I'm looking for an answer of 0, so that's too big. So because that's too big, there's no point me trying x equals 1.7 or 1.6 because they're going to be too big as well. So it's telling me that my answer is somewhere now between 1 and 1.5. So I'm going to try 1.3. Same thing again, explode my x, explode my x, take 5. On my calculator, bracket 1.3 cubed plus 2 bracket 1.3 take 5 equals, ooh, negative. So, and a value of x is 1.3 gives me a number that's less than 0, so it's too small. So there's no point me trying 1.2, it's too small. So my answer is going to be somewhere between 1.3 and 1.5. So I'm homing in and zooming in on where my answer is going to be. So I'm going to go 1.4. Explode, explode, plonk it in. Open bracket 1.4 cubed plus 2 open bracket 1.4 take 5 equals 0.544. We're back above 0 now, so that's too big. So x is 1.3 gives me an answer that's too small. X is 1.4 gives me an answer as too big. So my actual answer lives somewhere between those two consecutive 1 decimal place numbers. Now I only have to give my answer correct to 1 decimal place. So one of these is my solution. So I'm zooming in until I get it between two consecutive 1 decimal place numbers. So either 1.3 or 1.4 is my answer to 1 dp. So the question is, how do I decide which one? Well, in order to do that, first of all I'm going to blow my nose. And then I'll tell you. In order to do that, we need to go halfway now between these two. So I'm going to do x as 1.35 as my test. And let's see what that gives us, and then I'll explain how that's useful. So same formula, so we're going to explode it, but this time it's going to be 1.35 plus 2 1.35 take 5. So bracket 1.35 close bracket cubed plus 2 bracket 1.35 take 5 equals. That's too big. So that means everything between 1.35 and 1.4 is going to round too big. So, because that's too big, the answer is closer to 1.3, and everything between 1.35 and 1.30 rounds to 1.3. So you do your test halfway. If that comes out to be too big, the answer is going to end up rounding to 1.3. If that came out to be too small, the answer would end up rounding to 1.4. So that's too big. So x equals 1.3 to 1 decimal place. So there's 4 marks for that. 2 marks would get you to there. If you got to there, you get 2 marks. Then you get a mark for doing the test, and then 1 mark for getting the right conclusion from the test. If the test gives you an answer too big, it's the smaller of the 2 that you pick in. If the test gives you an answer too small, it's the bigger one. So 2 marks for getting to there, 1 mark for the test, 1 mark for your conclusion. So there's 4 marks for that, and again, just like the previous question on mean of group data and the one before that on Pythagoras, they can be practiced and learnt pretty quickly. And using your using your scientific calculator and this idea of exploding the x, that's quite an easy thing to practice and learn. Jones the sum, foundation topics, trial and improvement, give it a go.